3 years. The companies that I have worked in includes Larsen & Toubro, Infotech, Porter, and I'm currently working at Rapido. So my key skills include SQL, which is one of the major thing, then not restricted to Python, Power BI, Excel, and much more. So I use SQL on a daily basis to fetch data, to aggregate data, to drive some insights from the data. So what I think is SQL plays a major role when you want to get some information from the data. It becomes very easy when you are playing with SQL, and when you have a vast amount of data, SQL makes it very easy to solve those business problems. So today we'll be looking into joins, common table expressions, and also Windows function, which are advanced topics in SQL. So if you have some prior knowledge of SQL, then it's good. Even if you don't have, you will be able to take away a few things, like some of the understandings you will be able to get from this webinar. Okay, so now I'll share my screen. I'll start my presentation. I'll turn off my video for bandwidth issues. Yeah, so as I said, the topics today that will be covered are joins, CTE, and window functions. So let's talk about the first topic, which would be joins. Oh, so what are joins? So typically what we say is a join combines records from two tables. So join matches related column values in two tables. A query can contain 0 joins, 1 joins, or even multiple join operations. Second thing, why are joins used? So as I already said, they are used to join different tables on some specified columns, as you mentioned in the syntax. But the question here is, why do we store data in different tables? So for that, we will need to know the concept of normalization. So we won't be going in depth of normalization as of now, but on a high level, what I can say is normalization means removing redundancy from tables, redundancy as in duplicate data, to make the data consistent and remove anomalies. So what are anomalies? Usually when normalizing, we split data across multiple tables to remove certain anomalies like insertion anomaly, updation anomaly, deletion anomaly. You can research about it later, or if you know, then it's well and good. So because we are just restricted to 1 hour and the topics are join, CTE, and window function, I won't be covering normalization as of now. So in normalization, usually the data is split across multiple tables. Then there are relations that are established between these tables so that later they can be joined for some analytical purposes. So these joins, mainly they are created out using primary and foreign keys. So what are primary and foreign keys? The primary key is a key which is unique and not null. And that can be only one column or a set of columns which will be present in a single table. So you can say in a single table, there will be only one primary key. Now, when you talk about foreign key is a key which will be deriving from a primary key of a different table. So you can also say that it is a key which is a primary key that is referenced from some other table when you join them. But there can be multiple questions when you talk about SQL, when you are doing some analysis. So let's suppose I have two tables. One table shows who are the friends that I have on Facebook. Second table shows who are my friends who are there on LinkedIn. Now, first question would be, how many of my friends are common on both Facebook and LinkedIn? So that question can be solved using inner join. Second is, how many of my friends are on Facebook but not on LinkedIn? That can be solved using left join. Then the third question is, how many of my friends are on LinkedIn but not on Facebook? That can be solved using right join. The last question can be, how many total friends do I have, irrespective of whether they are on both the platforms or any single platform? So these are the types of joins that we can use on a daily basis on the different set of operations that we do. There are two different other joins as well, which are self join and cross join, which you will understand when we see the practical demonstration for both. So let's start with the first join type, which is inner join. So what is inner join? If you see the diagram here for each of these joins, we will be referencing two tables. It is not restricted to two tables. There can be multiple tables when you are joining. So as of now, we will be only considering two tables and joining between two tables. So see, first there is one table, there is second table. When you join them using inner join, the highlighted part that will be shown as an output. Here the whole part is gray, which means this is the whole result, this is the whole result. And you combine them using inner join, only the parts which are common to both of these tables, and these parts means what? These are the rows. These are the data points. Whichever data points are common to both of these tables, they will be given to us as the output. Okay, so if you see here, there is 1, 2, there is 1, 3, and 4. When I do an inner join, only one will sustain, the others will be removed out from the results. Now, when you do a left join puts more emphasis on the left side table, which is the first table. Always refer to the first table as the left side table and the second table too as the right side table. So when I do a left join, all the emphasis that will be kept on the left table. So all the data points from the left table will be kept, irrespective of whether they are present in the right table or not. So now if you see, when I did the inner join, I only got 1 because that was present in both tables. But when I'm doing a left join, I have 1 also, but I also have 2, which is although not present in the right table, but we are getting a null value here. So left data is retained, but the right ones which are not there, they are removed. Similarly, if we do the reverse of this, we'll get a right join where the right ones are sustained and the left ones which are not there, they will be removed. When you do an outer join, it is kind of a combination of left and right join. It will combine both the tables. It will give all the data from the left table, all the data from the right table, and the data which are common between those, they will be only repeated once. Cross join is kind of a m into n thing. So if there are 5 rows here, if there are 5 rows here, so it will give you total output would be 25 rows. It will multiply each row, it will pair each row with each row of the other table. So this first row of one table will be paired with all the rows of the second table. In this way, you will be getting multiple combinations. Okay, so let's look at the first type of join, which is inner join. So what is the syntax for inner join? How do join syntaxes look like? So always joins will be executed when you're executing from. So I hope you know the SQL execution order. Even if you don't know, I'll tell you the first thing that executes whenever you write a query is not the select statement, it is the from clause. So whenever from runs, you will fetch the data. After from runs, there will be a where condition where you will filter out the data. Then whenever you have to do some grouping and something, select can't directly aggregate if your data is not grouped. So then grouping runs, then your select runs, then after grouping your having runs, then select, then limit and everything, order by. So this is how the order of SQL query runs. Now, when you say about syntax for join, so syntax will be typically same across all the join types. The only thing that would change is how you mention the join name. So when I only specify join, it means that by default, it is an inner join. Okay. So this is the syntax. Forget the select part as of now. Just look at the from part. So what is the first thing that our query will do? It has to bring the table. It has to bring all the data points so that so whenever you're joining, as I said, it should be on some particular columns. You have to give some key based on which the two tables should be joined. Okay. So I'm writing first table, I'm joining this becomes my left table, this becomes my right table. So now I'm joining them on name. It is not compulsory that this names, they will be similar across both the tables. So I just have to specify which column name I want to connect it to. Even if I say that facebook.name is equal to linkedin.number of connections, it won't matter, but it won't be giving me any results because none of the rows are matching in these columns. When this thing matches, this entire row comes and sits beside it. Now let's see how it works. So suppose I'm doing an inner join. So now first thing I'm doing on what? I'm doing a name. So first thing it will come on the name. It will see the first name. It will go to the second table. It will compare the first name with all the other rows that it has. So Matt will be compared to first Matt. If you see, when it compares Matt, it becomes green. So this will be paired with this. It doesn't matter that if the Matt is repeated multiple times, this will also get repeated multiple times. That we'll see in a later example. So first thing, see, Matt got matched with Matt and it got the number of friends that Matt has and number of friends that he has on LinkedIn. Similarly for Lisa, for Jeff, we don't have any row here, so we are not getting Jeff in the output. Sarah, we have a row, so total we are getting 3 rows as the output. Understood? Anyone has any doubts in this, or anything they want to say, any questions, anything?
No, as of now.
So we are good to go for the next. Is someone writing something? No. Okay. Feel free to interrupt me in between. If you have any doubts, I will be happy to clear it. So next thing on joins. Now if you see, there is Sarah repeated in this table. This is also inner join only. See, the Sarah here is only repeated once, but in the second table we have it twice. So the question here will be, how will they be mapped? Okay. So now here comes the topic of type of relation that we have in between the tables. So there can be multiple types of relations. So one of them is one-to-one, one-to-many, many-to-one, and many-to-many. So what is one-to-one? When I was doing a mapping here, I know that this row is this data item is present only once here, and this will be only present once here. So I can say that it will be only mapped one time to the second table. Each data item will be mapped only one time. So that can be a one-to-one situation. What is one-to-many situation? Now if you see, Sarah is only present one time here, but Sarah is present multiple times here. So in this case, Sarah has to pair it up with both of these data rows, because it doesn't know that if this Sarah is different from both of these Sarahs or not. So it will pair pair with both of them, and then it will give you two separate rows along with this same info. So that becomes one-to-many. One relation here is present multiple times here. When you look at from this perspective, from a LinkedIn perspective to Facebook perspective, you will say that it is many-to-one, because many of these names, many of these single names, they are only present one time. It is not compulsory that it will be present one time, but what we can see as of now is that it is only present one time. So you can say that it is a many-to-one relationship. Okay. Then there is many-to-many, and as you would have understood, there will be many data points here, there will be many data points here. So each data point will be paired with each data point of here. So it will become again kind of a cross join, which will be n-to-n. So now if you see, Matt will be paired with Matt, Lisa will be paired with Lisa, Jeff has no one to pair with. Because it is an inner join, Jeff won't be kept because there is no Jeff here. If there would have been Jeff, then Jeff would have retained. But since the name is not present in this table, this will be eliminated. Next is Sarah. Sarah is present once here, so it will be mapped once. Again, it will be mapped with the last item. Okay. If you want to see one more example of inner join, so here we have a name table for students of standard 10 and a marks table for students of standard 10. So names table, why are the tables separated? So this marks, they will be updated based on the semesters, but this names, they will be attached to this roll numbers irrespective of whether they are getting any kind of marks. Just a second here. So now whenever I want to do some analysis, whenever I want to see who got the maximum marks, I have to somehow get all the marks attached to the names, to their names. Because every time I want to get it on a name level, who was the person who got the highest marks. So how do I join them? So I have to have some common parameter or common column based on which I will join these two tables, right? In this case, what can you say? What is the common column on which I can join?
Roll number.
Yeah.
Roll number.
Now the question here is, the roll number column name here is roll number, here it is roll. Can I join this?
Yes, sir.
Yes. Yeah. So we can join it. As I said, it depends entirely on us on what column we are joining. I can also say that join this roll number with this marks. Then it will do a comparison of what this will compare. This one is equal to 90. If this one is present in this column or not, then only this data points will come and attach here. But as I know from the table relations, I will know more about my company's database or something. I know that these two tables can be mapped on roll numbers, so I will map them on roll numbers. Now here comes the syntax for our join. So how does the syntax look like? We will first write the from condition. As a means, we are just giving an alias to this because this is a relatively bigger name for the table. We'll just give an alias so that we can further reference it using a shorter name. Now I'm saying that join this. If I'm not saying join, what does it mean? If I'm not specifying the type of join, what does it mean?
Inner join.
Inner
Correct.
join.
Inner join.
Correct. So now I'm doing an inner join of what? 10 name with 10 marks. These both are for the same standard, but they are just separated because, as I said, normalization. So now I'm joining them on roll numbers. Now if you see, what will be the kind of results that we get on a different type of joins. So first, let's see what will be inner join. Now, when I say inner join, so what I said about inner join, that only the items which are present in both of the tables will be kept. And what will be those items that will be compared? The thing that I am using to compare this. I'm saying roll number, right? So it won't bother about name, yeah, marks. It will only bother about if the roll number is matching here or not. So this, if there are no roll numbers, suppose this starts from 7, 8, 9, 10, it won't give me any results because nothing is matching. So it will give me 0 results. Now, when I do inner join, let's see the common thing. So first common thing would be this one this, one this. So how will they decide? And one more thing to keep in mind is ki, even if I'm saying that this roll number is same as this roll number, it would never happen ki only this will be kept, because you will say that these both have the same data, right? So why both of these columns are repeated? So in the case of inner join, this makes sense. But when you do left or right join, then you'll understand that this roll number might have some different values, this roll number might have some different values, because it is not necessary that the right one will have all the values that are present in the right one. So that's why whenever SQL joins, it keeps all the rows that you are having in both of the tables. Now it depends on you to use in the select statement whichever columns you want to highlight or give as the output. Okay, so now this 1 matches with 1, 2, 3, 4, these matches. 5 is not matching. Okay, the 5 is not there in the right table. And if you see from the right side's perspective, 6 is there here, but 6 is, we don't have a name identity for the 6. So I'm doing an inner join. I want that these should be present in both of these tables. Either I don't want the results. So that's why 5 and 6, they both will be neglected. And the final output that I will be getting is for these 4 people. Understood?
Yes, sir.
Yeah. So now even if you see that in this example, we saw what? We saw that Sarah is present one time here and Sarah is present multiple times here. Now in this example, you will see Sarah is present multiple times here, but only one time here. So that will also perform the same thing. This first Sarah will get mapped to this Sarah, then output will be given. Then again, this Sarah will be mapped to this Sarah, because see, it is searching, right? It is not searching all of them with all of them. It is searching one by one. It will go see this one. It will compare however how much Matt are there. Then it will compare Lisa, then Sarah. So whenever it sees Sarah for the 4th row, it will again pair it up with Sarah. So eventually these both will end up giving us same results. Okay. So now the next thing is left or right join. So what is left join? See, now the syntax is very similar to what we saw in inner join. The only difference here is what? The addition of this keyword called left. So when I specify left, it means that Facebook is the left table. It is given more emphasis rather than LinkedIn. Okay, so now what I said about left join, that all the data points on the left will be kept. So simply you can say that all these names and friends, irrespective of whether they are present in the right one, they will be noted down. Now it is on the right one that they are matching or not. If they are not matching, that will give us null. So see, Matt is there. So Matt will give us some results. Then there is Lisa. Then there is Jeff, who is not present in the right table, which is why we'll get Jeff's Facebook information. But since there is no information about him on LinkedIn, so we'll give him null. Okay. For Sarah, we have the information. So we are giving it now. Understood? What is left join?
Yes.
Okay, so next would be right join, which is exactly opposite. So here is a catch in the syntax. Here you have to write, here right should be written. So it would be right join LinkedIn. The same thing. Now the right table will be given more priority rather than the left table. All the data points from the right table will be present. If they are not there in the left table, then also they will be kept, but the left information will be kept null. So it's exactly opposite to what we saw in left join. But there is one more thing. Why would I use right join if I can just interchange this tables? If I keep LinkedIn on the left side, if I keep Facebook on the right side, I do a left join, then eventually it will give me same results as right join, right? Are you getting it?
Yes.
So usually that happens in the IT industry, that mostly people, like only 1 to 5% of the times they use right join, because when you have to join multiple tables, then you can't rearrange them sometimes. So you have to use right join, but mostly people resort to using left join only. They'll just interchange the positions of these two. If I keep it on the left side, if I keep it on the right side, and then do a left join, then eventually what will happen? LinkedIn is already given emphasis, and in right join also, now at this position LinkedIn is given emphasis. So that is what happens. So if you want to see the other example for this, now see here, if I do a left join here, what do you think, what will be the rows that will be kept? If I do a left join between these two tables, this is my left table, this is my right table, how many, which rows will be present?
1 to 4.
1 to 4 from where?
Fifth
Of which
roll
one?
number 1 to 4 will be fetched, and fifth will be null.
So fifth will be null only for the right table. For the left one, it will be there.
Exactly.
And 6, what about 6?
Record will not be inserted.
Correct. 6 won't even exist, because this is left join. So I will simply just write this 5 rows first. I won't care about this, because even if there are additional rows here that are not there, left join won't consider them. Now it will only, once it has written all of them, it will just see if there are pairings or not. If there are not pairings, it will directly give them null. So now it sees that for 1 it has a pairing, for 2, 3, 4 it has a pairing, for 5 it doesn't has the marks record, so it will give them null. Now if I do a right join here, I'll get all this first, which will be 1 to 6. See, 1 to 6 will be given first. Now for 6, I don't have any information of name, so this will be given null. Understood? Now what is full outer join? So if you just look at how full outer join looks like, this is how full outer join looks like. Now if you see, this is somehow a combination of left and right join. You will get all the data from the left table, you will get all the data from the right table, and only the common ones will be repeated once. So now if I do a full join here, what will happen? All the data will be kept, but I don't have any record matching with this. So this will be kept null, like this. Similarly, for the right side, all the data will be kept, but I don't have any record for this one on the left side, so this will be given null. So if you compare this, you will see that it is kind of a combination between of left and right join. Understood? So even if you see it here, see, Jeff is present here, but it is not present here. Louis is present here, but Louis is not present here. Now, even though they are not present on the opposite tables, we will get the result. See, Jeff doesn't has any equivalent record on the LinkedIn side, so we'll get null. Now, Louis doesn't has any equivalent record on the Facebook side, so we'll get null from the Facebook side for Louis. Understood? Okay then. Now let's look at what is cross join. Cross join simply means there might be scenarios where you want to pair up each. Suppose I have a class of 10 students and I have a class of other 20 students. I want to make an examination seat. I want to give them seatings for examination, and I want to keep 2 people on bench from 2 different classes. So I want to pair each one of them. So this is how the pairing will be done. I can then select from those pairings. So each record will be paired with the other record of the next table. So this mat this Matt will be paired with this Matt, this Lisa, Sarah. Then Lisa will come. Lisa will be paired with Matt, Lisa, and Sarah. Then Jeff will come. It will be paired with Matt, Lisa, and Sarah. So there are very rare, there are very certain scenarios where cross join is used, and that is case specific. So whenever you come across those scenarios, you will eventually figure out that cross join is the only solution that I have here. Okay. There is one more thing which is self join. So let me see the timing. Self join is something that you will be joining the same table to itself, so that you, because there is some hierarchical data. If I go in depth of self join, it will become, the lecture will overshoot the time. So let's just first continue window functions, and if I have some time remaining in my hand, I'll explain you about self joins. Is that fine?
Yes.
Okay.
Yeah. So what are window functions? Why do we use window functions? So whenever you group by, you would have sometimes wanted that I want this data, these two columns to be present, but I don't want that this grouping should hamper it, because every time you try to group by, it says that all the columns which are non-aggregated in the select statement, they should also be present in the group by. But if you include those columns in the group by, the level of data changes. So for example, now see this table. I have analyst his salary, analyst his salary. If I drew a group by, normal group by, I can't directly do group. I can't directly keep this table, these column as raw and do the group by here. It won't give me the average salary if I do a group by using average salary. So it won't give me the average salary at each row. If I want to compare ki this person's salary is 3,100, I want to compare it with the average salary of all the analysts. So total would be 3,100 plus 2,900, 3250 divided by 3. That would be average what an analyst gets. So I want to compare the benchmarks that on average, the one when compared to the average salary, how much is this person getting more, how much is this person getting more. But if I do a group by, I can't do that, because group by will group this thing. Even if I don't group this thing, it will do the average on a single row item. It will not do the average based on this whole group. So how do we tackle this problem? So that is when the window functions come into picture. What happens in window function is you create a kind of logical window in which the operations will happen. If you see this in group by, in aggregate functions, it will aggregate all of them and give you an aggregated result. In window functions, the order that you pass in, or the window that you pass in, based on that, it will do the aggregate at each step. It will not do the aggregate on the whole data or on a particular group. It will only do at each stepwise, which is passed using a order by clause or a partition clause. So this is how the results. Now, how can I use this data? When I use window function, I'm getting that on an average, the analyst earns 3083. So I can say that this person, he is earning more than the average salary of any analyst. This person, he is underpaid than the average salary. This person, he is also paid more. This is how you can use this data. But this data, will it give me any inference? No. I have to manually see that what is the average salary. I have to compare it with this. Then only I will be able to do it. Or I have to again do some joins. I have to repeat it at each row. Then only I will be able to do it. But I can't do it in a single step. So let's see what is window function and what is the syntax and what are the different types of window function that we have. So this is the window function. So window function will be the list of functions that we have. So these are the list of functions that we can use with window function. Aggregation functions will be average, max, min, sum, count. Ranking, for ranking, we have this 5 function. For value, which is lag, lead, first value, and last value, you can use these functions. I'll show you demonstration for some of this, that is lag, lead, rank, row number, sum, count. So window function will be these. Out of this window function, we'll give some any window function. The over clause is necessary so that you can create a window. How is over clause necessary? Now see this one. I have a roll number and a marks table. I want to give them rankings. Okay. I want to say that whoever scored, if I want to get the third person, the person who scored third rank, how would I get it? Can someone tell me?
By using limit function.
So limit you can use. I agree that, but limit will give not only the third row, but it will give you the starting 3 rows, right?
We can use dance rank function.
Yeah, so that is what we are coming into. We'll use window functions here. So window functions for ranking, we have 3 functions: row number, rank, and dense rank. How do we use this? And what is the purpose of this over clause? First, tell me, is my screen like, is the size proper, or should I increase this size? Is it visible to everyone?
Zoom it a bit.
Little bit if you can increase.
Okay. Visible now?
Yeah, better.
Okay. So now first we have, if you see the syntax here, we have two things here. One is partition by clause and one is order by clause. Within over, what is this over? This over only creates the window that you want to feed to this aggregation function. Without this window, this aggregation function, even if I use sum, that would become a normal aggregation function. That won't be working on some window. If I want to create a window on which it will be iterating at each step, I have to use over. So now, first thing, we'll see it without partition by. So what is order by? When I say order by, I want to do what? I want to order it based on marks, right? I want to give them rankings based on what marks they have scored, but the marks should be highest first. So it will be descending. So when I do this, what it does is it will first sort this table. So now this has gone into a logical window. This won't be shown you as the output. This won't be the final output. This is just a logical window within which the select statement will play now, or this aggregate function or the ranking function will play now. So now this over clause has done one thing, which is sorting this based on a descending order. Now there is only one purpose that the row number will serve. It will give you a monotonically increasing list of numbers just like this. Correct? So now I have created it as a column. I suppose I say that it is the column name is row. Now in further, when I want to use the third ranker, I can directly say that where row is equal to 3. Right? I only get this row, rather than taking all the unnecessary data. Now in this case, the data is small. What if I say that you want to use limit and I want to say that get me the student who is 1000th number. You want to limit 1000 and get the top 1000 students. You have to specifically get that 1000th row. So for that, you have to do some sort of ranking. Even if I tell you that I want the student who came 1000th, who took admission on the 1000th number. So what will I look into that? Which parameter would I consider? I will consider the admission date. I'll sort them first based on an admission date, based on which I'll give them a ranking or row number. And on that admission date, if whoever person is the 1000th person who joined, that would be directly filtered out using the where condition. So this is where ranking functions makes our life easy, right? So now what is the difference between row number, rank, and dense rank? So now the same thing, if you see the below output, see, it has first sorted it. It will now first implement row number. Row number will give you monotonically increasing list, irrespective of whether these marks are repeating or not. But now if you see this person, they have got the same marks, right? So if I see, if he says sometimes, this person says that I have also scored this same marks, why are you giving me third rank and giving him second rank? So in that cases, we have to give them both same priority because they have scored the same marks and there is no other parameter based on which a bias will be created. So I will use rank function. What does rank function do? Rank function will again work as the same as the row number, but it will repeat itself whenever this value for the order by whatever you are using in order by marks, right? Based on marks only you are sorting. So if that value is repeating in marks, it will repeat the rank also. So now if you see 1, then we are getting 2, then we are getting 2. But again, there is a catch that it has taken the place of 3, right? It will not continue from 3, it will continue from 4 because it has already taken the placeholder of 3, and it knows that 3's place is gone, so it will take 4. Now after 4, we have a different number, we are getting 5. Then again 90 is repeating. So suppose there is some 89 here. So what do you think? What will rank give me? What rank will be given here?
7.
7. Why? Because the placeholder for 6 is taken by this 5. Now, if we compare this to dense rank, there is only one difference, that if you see the streak is breaking here. Whenever there is a repetition, it breaks the streak. The dense rank won't break the streak, it will continue the streak. So that is 1 to 2. Then it is not taking that placeholder, it is giving them directly 3, then 4, then 4. Then even if someone comes here, it will be 5. So if someone tells me, give me the top 5 students who scored, and it is not limited to the number of students, I can use dense rank, because top 5 includes how many students now? Top 5 will now include 3, 5, 6, 7 people. Even though it is top 5, there are, due to some same scores, we are giving 7 people the award. Now if you see rank is not giving me 7 people, it is giving me 6 people. Even if it repeats, then it will give me 6 people, then increase. Row number will never change. Row number will give me, the count will always be, if I do less than 5 or less than equal to 5, it will always give me 5 rows only. Irrespective, even if all these people are 95, then only there also it will give some people, it will give them 95 based on this. So it is not, and also it is not compulsory that this will be only limited to one order by. I can also say that if there is a clashing in marks, I want to order it based on roll number. So I can give a second column as a second priority for ordering. So if there is a clash, so see 94 and 94 are clashing. So when there is a clash, use the roll number to decide who will be first or second. So here 2 will be first, 4 will be second. Okay. Now, what if I add a factor of gender? I want to get the person who scored 3rd rank in male. I want to get the person who scored 2nd rank in female. How would I do that? This I got on an overall level. Even if I introduce gender now, okay. If I only do order by, it won't consider the gender in fact, and this consideration it won't take. It will directly do what? It will do this, right? Now it will give row numbers. Even if I say, suppose I am taking this query, I don't use partition by, and I use gender as the second option in my order by. If marks are same, then give them gender. Or even if I say that first order it by gender, then order it by marks. Okay. So first let's see how the partition by results will look. Then we'll compare it with how order by wala results will look. So I want to do partition. I did a partition on this way, this field, where we know that there is some kind of categorical variable. We have 2 genders present, whether it be 3, 4. It will automatically, whenever you say that partition by gender, it will automatically segregate them into different groups. So one group is for F, one group is for male, right? Now within this group, now the order by will happen. So first thing, partition by will run. Second thing, order by will run. So this order by will be running based on marks in a descending fashion. So when the groups are made, it is not necessary that this marks, they will be in this descending order only. This might happen that this marks comes first, this comes second, although there is a wall between the other groups. But we want to give row numbers or ranking, whatever is it, within those individual groups. So we have to sort the marks or whatever logic you are working on. Now, when I sort this, if you see, within it is not sorting this marks on an overall level. This 95, it is getting first, but it's not getting first in the overall data. It is getting first in the gender male. Same for 94, which is in female, it is getting first. Now, if I use row number, rank, or dense rank, when I'm using this function. This function has no purpose for this window function, for creating this windows or anything. They just simply do their work by whatever function what they are assigned to. Even if I do a sum is supposed to do addition and nothing else. The main game that you have, that is with the over clause. How you're creating that window, what logic the window is built on that only you will, all the operations will be performed. Now here when I apply row number, typically if I don't have a partition by, I'll get increasing list of numbers 1 2 3 4 5 6 7 8 9. But whenever you apply partition by, the number resets itself after each group. Well, what is the group? The partition by group. So here I say that gender is female. So 1 2 3 4. After 4, it will reset itself. It will forget when it comes to the other group. It will forget that there was another group that exists. It will forget about this data. It will again start make a fresh start. So it will again do 1 2 3 4. Now if I see rank, same thing. It will do 1 1 for rank. What I said, that it will take the placeholder of whichever number it is repeating. So 1 1 3 4. For this one 1 2, then the rank and marks are same. So 3 3. Same for dense rank. The difference is here it is taking placeholder, but here it is not taking the placeholders. Right? Here now you'll see this dense rank. This is how partition by does. Now what if I do the row number based on ordering only on gender and marks? So let's say I first order them based on gender. Okay. Now if you see, now once they are ordered based on gender, then only they will be ordered based on marks whenever there is a clash in the gender. So in here there is a clash, so they ordered it by marks. There is a clash, so they ordered it by marks. Correct? So if you will say that, see, the organization, it is same as what you saw in partition by. Now what will be the difference here? The only difference would be the working of this row number thing. Now since we haven't added a partition by, it will give me increasing list. Now I won't know that where is the third person, third ranker from male is sitting on. If he is on 7th position, if he is on 8th position, here I directly know that he will be third, she will be third. Here I don't know that, which is why partition by comes into picture. Understood? Is it clear?
Yes.
Okay. So now there are multiple things. See, a window function. This is the name of the window function that we use. What are the window functions? These are the window function. What is the expression? Now in row number, rank, dense rank, we don't need any expression. But when you are doing sum or something, sum or average or something, you have to give some expression, because whenever you are doing sum, average, count, min, max, you can't do it on an overall table. You have to specify the column on which you will be adding. So there the expression you will be feeding. Then you have the over clause, which contains partition by. This over only signifies that it is a window function. Then you will have partition by. It divides the row into partition, so we can specify which rows to use. Then partition list. Partition list is what we call as the partition by column. Order by and order list. Order by is the keyword, and here will be the column based on which you want to order. Rows, this is very optional, like how many rows you want to precede, how many rows you want to skip, kind of thing. But it is very optional. You can Google it later to, if you have any purpose, or if you anything use it. Then frame clause, it is much of the offset from which you want to start the row number. So if I say that I want to start the ranking from row number 2, so here it will be offset 2, kind of thing. Now there are some other things also that you can do using window functions. You can do a cumulative sum. So how do cumulative sum works? What is cumulative sum? It is running total. So now if I want to say this is my record of how many miles I have driven each day. So on January 1, I drove 60 miles. On January 2, I drove 80 miles. On January 3, I drove 10 miles. Like that. if I simply do a group by, what do you think will be the output? How many rows will I get when I do a group by just for the total miles driven? If I add it, I will get what? I will only get a single row, which will give me what? 300. So that will give me that I totally rode 300, totally drove 300 miles. But how do I know that on the starting 2 days, how many miles I drove? For the starting 3 days, how many miles I drove? Total, how many miles I drove? So that things group by won't give me. Even if I say that group by day, on a day level, if I group, it will give me single items. It will add this item for that this particular day. This will create groups. These all are separate groups. This is January 1, this is January 2, 3, 4. So it will give me 60, 80, 10, 150, which will be eventually same as this. But what window functions change is window functions create a step. Window functions, when I say, so see, I'm doing sum of miles driven, I'm not using any group by, I'm doing it on what? Order by day. And first, the days will be sorted, right? And I'm doing sum of what? Miles driven. So when I'm doing order by day, when it comes to the first row, right? Till the first row, it won't be having visibility of the next rows, what it has. So it will, till the first row, what was the sum? 60. So it will give you 60. Then it will come to the second row. When it comes to the second row, this is already sorted on a day basis. So when it comes to the second row, it will do the sum, but it will do the sum of all the prior values that it had. So it will do say 80 plus 60, which would be 140. Now when it comes to the third row, it will get visibility of these three rows. Then it will do the sum of these three rows and give me total of 80 plus 60 plus 10, which is 150. Now when it comes to the last row, it will do it now has visibility of all the data. So now it will add all of them and give me 150 plus 150, which would be eventually 300. So this data now can give me multiple conclusions that I totally what all things can I derive from this. I can say that till day second I drove 140 miles. Till day third I only drove 150, which means that only 10 difference. And at last, till the at the end of day 4, I totally drove how much? 300 miles. So I'm even getting the total along with a segregation or bifurcation of how much I totally drove, combining all the days till the previous day or whatever day it is. This is how you use window function for doing cumulative sum or running total. If you compare it with group by would have given me what? This directly it would have given me sum of miles. If I do a sum, if I do directly do sum of miles driving, I remove this over clause, remove this day and mile driving, I'll get 300. But running total is giving me something like this. Now the order of execution has a slight change when window functions are introduced. As I said, from and join will again execute first, where will execute second, group by, then you have those aggregate functions, then having, then there is the window function which will be executed when before the select. So this window functions, they make what do we say, logical window. Then this select, then whatever columns you have is select function, whatever operation, other operations you have, that will be run. Then in the select only you have distinct, so that will run, then union, order by, offset. Understood? So this is not the only use case that you will have for window functions. You also have lag and lead. You also have row number, rank, tense rank. For lag and lead, I have a post that I have created on LinkedIn. I have some references here. You can directly see. You will be able to get it. Cumulative sum also I have for CTEs. Now let me just explain you what CTEs are and how do you use CTEs. So suppose I build this query, right? This query is giving me output like this. Now, what if I want to get the person who scored third? Suppose I want to say that where roll number is equal to third. And I say that this column is roll. What will I do? Will I directly write where role is greater than 3 or equal to 3. Will this work?
No,
Why?
because of the
It will only fetch the third roll number.
What?
It
Sorry,
will
sorry.
fetch the roll number third.
No, sorry. This way, will this work? If I'm taking,
because of the order of execution, select
yeah,
select
correct. So, what was the order of execution again? See, first from will execute, then where will execute. So once from executes, from is here. From took all the data, which is this data. In this data, do you see any column named as row? Because select hasn't executed yet. So where will this columns come from? We want to first build this table, then only on the top of it we can filter it, right? And we can't say that I will take this where, I'll write it before select, then where will execute after select. That won't happen, because there is a reason for which order of execution is the way it is. So what I can do, I can suppose I say, I can introduce a concept of subqueries. I can say that let this be my table. I am taking the data from this table. Suppose I say that this is table A. Now I say that select star from this table. Now this select can filter out where row is equal to 1 or 3 or whatever it is. Right. So what will happen now? So this select statement, it will be running first. This will go to the from clause of this select statement. But when this from enters, it is not having a ready-made table that we are used to have. Here we have a ready-made table which is named as example. But here we don't have that ready-made table. So this will again start its order of execution, which is first it will execute from, then it will execute the select, the rankings, then it will order by. Then once this data is computed and we have the table ready, it will give me something like this. Now this table, it is fed on to, once it is ready, this table will be fed to this select statement. Now when this select statement, then when this from fetches things, now this from has what? This from has this table. Whereas when I was using where in this one, it had this table, which is why I was not able to use where condition. Now this from, this will be getting this table, which has pre-built row, rank and dense rank. So after this from, what will execute? Where. Now this where is not for the inner query, it is for the outer query, right? So this where will now have visibility to what is row, rank and dense rank, and we can directly filter out where row is equal to 3. So now it will only give me the row which has row is equal to 3, which will be this one. Understood? This is the concept of subquery. Now this sometimes becomes very complex. Suppose I want to do something more. I want some other things. I can also do select star from this. Again, I will put this one into a subquery. Let's say I'm not doing anything. I'm saying if rank is equal to, I'm just checking it. So this becomes very complex to understand. So in that cases, we go for CTEs. What are CTEs? CTEs are common table expression. There's nothing much about CTE exceptionally different from this subqueries. We'll just take the query that we have. Else, if anyone would have used Python, they know how functions are built. Similarly, to what functions are built in Python, we'll suppose say this is my CTE1. I'll give this query here. Okay. Then I create CTE2. Just a second. In CTE2, what I want that select star from what CTE1, where my row is equal to 3. Now, there should be always a final select statement, which should not be in a city. I will say select star from city 2, suppose where rank is equal to 2. Now, what all things will happen? The first thing that will execute is not these things. Even if you have used Python, you build functions, but the functions won't be executed until and unless you call them. Similarly, these CTEs, they won't execute until and unless they are called by the main select statement. There can be only one main select statement, which is this. So SQL will directly go to this select statement. It will follow the execution order. It will see the from. It will see that there is some table called a CTE2 from where it is deriving the results. It will go find for CTE2. It will see that there is CTE2, but it is not pre-built. Then again the execution order will start. It will go to the from clause. It will see that there is CTE1. CTE1 is also not ready. So it will go to CTE1. CTE1 will then go to the from clause. It will build the table, which will look like this. Then it will pass that table to CTE2, wherein CTE2 will now filter out using this condition. Then it will, and CTE2 will only give me what now? This row, this single row will be passed on to this query where I will check for something. As of now, I'm checking for rank is equal to 2, so it will be proven true, so it will be kept. But the objective here is, why do we use CTE? What do you think? Isn't it more cleaner than what we had in subqueries? More cleaner and easy to read? The execution anyways remains the same, right? But the way I am segregating them, if someone else looks at my code, they will be easily able to figure out that what does this serve. I say that this is my ranking city. I can name it anything, right?
It is easy to debugging.
I can say this is my filter city. So from the filter city, I'm getting this. So this naming conventions are also very important when you are working with SQL. So this helps you when you are debugging a bigger code, longer code, right? Yeah, so this was all about CTEs. So on a higher note, we have almost completed all the topics that we were planned for today, which included joins, CTEs, and window functions, along with some examples of window functions. If you want more resources on how do you, what are the different, how do you use the different window functions, feel free to reach out to us. We'll be any day fine to help you. So yeah, on that note, thank you guys, everyone, for joining, for such a great response to this webinar. I'm glad that so many people joined. So yeah, looking forward to having more such webinars in the future. So thank you.